Welcome to Vision Class and welcome back to this Singapore Mathematics on Complex Numbers. We are looking at modulus of the complex number and we are now on example 3. Example 3 says that we are given two complex numbers, z1 as 3i, z2 as 2 minus 2i, and then they're asking us to find the magnitude of z1 plus z2. So the solution to this is part A. They're saying that we need to find the absolute or the magnitude of z1 plus z2. Now, before we find the absolute of z1 plus z2, let us first find z1 plus z2. What is the joint complex representation of z1 plus z2? And then from there, we shall go ahead to find let us find z1 plus z2 first. z1 plus z2 equals to, what is z1? z1 is 3i plus, what is z2? z2 is 2 minus 2i. Remember, we have done addition of complex numbers, so let's just add them. We collect the imaginary parts together and the real parts together. The first complex number z1 does not have a real part. In other words, its real part is 0. So let's add the imaginary parts together. That is 3i minus 2i, because it is negative 2i, it is carrying a negative sign, and then we add plus 2. And then what is 3i minus 2i? That is simply 1i, which is the same as I. It is I plus 2. Now we have got the value of z1 plus z2. Now this is the one for which we are going to get the magnitude. Therefore, from here now, you can say now, therefore, what is x? X is the real part of the complex number here, which is 2. What is y? Y is the coefficient of I, or the real part, which is, or the real number, which is trapped in the imaginary part, which is positive 1. There is a coefficient of 1 there. And then from here now, you can say now, therefore, the magnitude of z1 plus z2 equals to, remember, the formula is that we have the square root of x squared plus y squared. Then here we need to substitute for x and y. Here now it gives us here, what is the value of x? X is 2. We put in bracket and square it. Plus y. What is y? Y is 1. We put in brackets and square it. What is 2 squared? 2 squared is 4. Plus, what is 1 squared? 1 squared is 1. This gives us here now the square root of 5. And then you press the calculator. The square root of 5 is like 2.3 something. Square root of 5. It is 2.236. So this gives us here 2.2361 units. So this is the magnitude of z1 plus z2. And now going to part B. Part B is asking for the magnitude of z1 minus z2. So the first step is, let us get z1 minus z2. Now z1 minus z2 becomes, what is z1? z1 is 3i. So say 3i minus, if you look at z2, z2 has 2 terms. I remember we say that if you have 2 terms that you are subtracting away, you need to put them in the bracket. Why? Because the subtraction sign is going to alter the signs of those values. You can say here minus, then open the bracket, 2 minus 2i. And then proceed here to give us 3i negative 2. Because here there is an imaginary 1 here. Negative 1 times 2 is negative 2. Negative 1 times negative 2i gives us positive 2i. And then this now gives us, let's collect the like terms. We shall have here 3i plus 2i. Those are the imaginary parts which are like. And then we subtract 2. What is 3i plus 2i? This gives us 5i minus 2. Now This is just the value for z1 minus z2. But the question was saying that we are looking for the absolute value, the magnitude, the length, or the modulus of z1 minus z2. Therefore, here we shall now say therefore. Before I go there, let's deduce here. What is x? X is the real part, which is -2. -2. What is y? Y is the coefficient of I, which is 5. And then after me, you can say therefore the magnitude of z1 minus z2 equals to, state the formula clearly, which is x squared plus y squared, but the under square root. This gives us here, what is x? X is -2 plus what is y? Y is positive 5 squared. Also square this because the formula said we square x and y. This gives us, what is -2 squared? -2 squared is 4. Where's your calculator? This gives us here 4 plus what is 5 squared? 5 squared is 25. And then we add 25 plus 4, that is 29. I've said before that the moment you are left with only a single term under the root, that is when you press the square root. What is the square root of 29? Is 5 point something. 29 is 5.385. This gives us here 5.3852 units. So this is the answer for the magnitude of z1 minus z2. Some teachers or some solutions stop at square root of 29, which has this value. So even if you stop here, there is no so much penalty. Actually, this is the real answer. That is the absolute answer without any errors. This one, since we have rounded, we are subjected to having some errors. Now, part C. Part C says that we need to find the magnitude of z1, z2. This is a multiplication. Remember, z1, z2 means z1 times z2. And we were in position to handle that under multiplication. So this is a multiplication. So the first thing that we do, first get the multiplication of z1 times z2. So you just say here, z1, z2, this is the same as, what is z1? z1 is 3i. So we're multiplying, we put them in bracket, 3i, that is z1, times z2. z2 is 2 minus 2i. And then you multiply. z1 has only one term. So we shall just say 3i times 2, it gives us here 6i. 3i times negative 2i, it gives us a negative 6i squared. Remember, 3 times negative 2 is negative 6. I times I is I squared. Now from here, we go on and simplify. This gives us here 6i minus 6. But what is I squared? I squared is negative 1. This is a fundamental concept under complex numbers. We substitute for I squared as negative 1. Now this gives us here 6i plus negative 6 times negative 1 is plus positive 6. Now that is just the multiplication of z1 and z2. But the question is looking for the magnitude of z1 and z2. What do we do here? Here we just need to get the magnitude of this new complex number here. So what can we do here? What we can do is, what is x? X is the real part, which is 6. What is y? Y is the coefficient of I, which is also 6. Therefore, now the magnitude of z1, z2, remember the formula is square root of x squared plus y squared. This gives us now the square root of 6 squared plus 6 squared. What is 6 squared? 36. 36 plus 36, you get 72. 6 squared, 36 plus 36 is 72. Then you take the square root of 72. It is 8.4853 units. In mathematics, marks are also given for the shortest route that you have used as long as it is correct. Thank you.